Welcome dear students, we are in the CEC Gurukul lecture and we are discussing the electronic component, and today's topic is the fans, electrical fans. So we discussed the many type of fans and presently we are discussing the centrifugal fans, and these are classified according to the blade arrangement, and these are radial, airfoil and the forward and the backward type of the centrifugal fans. So, what are the major type of the centrifugal fan are the radial, forward curved and the backward curved. Radial fans are industrial, used in the industrial workshops, and it because of the high static pressure and ability to handle the heavily contaminated air streams. So, we use this type of the centrifugal fans, and because of its simple design, radial fans are well suited for high temperature and the medium blade tip speeds. So, this is the one type of the centrifugal fans, that is the radial fans, and it is the radial fans are the well suited for the high temperature and the medium blade tip speeds. Another type is the forward curved fans and are used in clean environments and that operates at a lower temperature, and they are well suited for the low tip speed and high air flow work, and they are the best suited for moving the large volume of the air against the relatively low pressures. So, forward curve fans worked on the low pressure and it produced the larger volume of the air. Another type is the backward inclined fans, and that are more efficient than the forward curved fans, and these are backward inclined fan reach their peak power consumption and then power demand drops off well within their usable airflow range, and this type of fan inclined fans, and they are also known as the non-overloading fans. Why it is called non-overloading fans? Because the changes in the static pressure do not overload the motor. So, it will not affect the loading on the motor because of the static pressure, and they change in the static pressure. So, you see on the screen that a different type of the centrifugal fans. You see paddle blade here, that is the radial, second is the forward. It is, you see that it is having a maximum number of blades as compared to the radial fans, and now at the last it is the backward curve fans, and it is also having a large number of the blades, and all are having its own utility and on applications. So, another type of the fan is the cross flow fans, and it is also called the tangential fans. Sometimes it is also known as the tubular fans, and it is patented in 1893 by the Paul Mortier. So, from the reference we can get this for all the detail of this type of cross flow fans, and it is used extensively in heating, ventilation and air conditioning, that is HVAC, especially in the ductless split air conditioning. We use this type of the cross flow fans, and the fan is usually long relative to its diameter. So, the flow remains approximately two-dimensional away from the ends, and the cross flow fans uses an impeller with the forward curved blades, and it placed in the housing consisting of a rear wall and a vortex wall. So, unlike the radial machine, the main flow moves transversely across the impeller, passing the blading twice. You see here on the screen, left hand side, this is the This is the type of the fan. You see, this is the cross flow fan. Now you see there is a motor, that is an impeller, and this is a housing on which the fan is rotating. So it works on the double movement. So right hand side, it is a schematic diagram. It is having a large number of the blades, and it rotates and it covered the stream. The flow within the cross flow fans may be broken up to into the three distinct regions. How? Number one is the vortex region near the fan discharge, that is called the eccentric vortex, and the through flow region, and third is the padding region, directly opposite to the vortex region. So both the vortex and the padding region are dissipative, and a result only the portion of the impeller imparts the usable work on the flow. This is the cross flow fan, or this is the or we can say it is a transverse fan, and this is a two-stage partial admission machine, because the popularity of the cross flow fan in HVAC comes from its compactness, shapes, quiet operation, and ability to provide a high pressure coefficient. That is why they are used in the split ACs. Efficiently, a rectangular fan in terms of the inlet and outlet geometry, the diameter readily scales to fit the available space, and the length is adjustable to meet the flow rate requirements for the particular application. And cross flow fan is basically a centrifugal fan in which the air flows straight through the fan inside of the at the right angle. So the rotor of the cross flow fan is covered to create a pressure differential. This cross flow fans are made to have a double circular arc rear wall that with the thick vortex wall that decreases in the radial gap. So the gap decreases in the direction of the fan's impeller rotation. The rear wall of the fan has a long spiral profile, while the vortex stabilizer in the horizontal thin wall with the rounded edge is used. So the resultant pressure difference allows air to flow straight through the fan. So that is why the rear wall has a log spiral profile, while the vortex stabilizer is a horizontal thin wall, and the air to flow straight through the fan here, that because of the resultant pressure difference. And even though the fan blades counter the flow of air or one side of the rotation, and again it works, if it is rotated in one side, then it will give the resultant air. So cross flow fans give the air flow along the entire width of the fan. However, they are noisier than the ordinary centrifugal fans, but these type of fan oftenly used in the ductless air conditioners, air doors, and in some type of laptop coolers, in automobiles ventilation system, and moreover they are used for cooling in medium size equipments like photocopiers also. So in photocopier and in laptop coolers we use the cross flow fans. Another type of the fan is the bladeless fans. How they are? Dyson air multiplier fans introduces this type of the bladeless fan, and it was discovered in 2009 and popularized design by the Toshiba, that produces a fan that has no exposed fan blades or other visibly moving parts, unless augmented by other features such as the oscillation and the directional adjustment. Means this type of bladeless fan not use the no exposed the fan blades. A relatively small quantity of air from a high pressure bladed impeller fans which is contained inside the base rather than the exposed induces the slower flow of a large air mass through the circular or oval shaped opening via an low pressure area created by a airfoil surface shape. So, air curtains, air doors also utilize this effect to help retain the warm or cool air within an otherwise exposed area that lacks a cover or a door. Air curtains are commonly used on open face dairy freezers, moreover in the vegetable displays to help retain the chilled air within the cabinet using a laminar air flow circulating across the display opening. Sometime for the air blower we use this type of fans. The air flow is typically generated by a mechanical fan or any type of described that is in the hidden display cabinet, and HVAC linear slot diffusers also utilize the effect to increase the air flow evenly in the rooms, that is compared to the registers, while reducing the energy used by the air handling the unit blower. So, these are the air flow fan that is certainly used, that these are the bladeless fan and they are used in many devices. Now, next we discuss the various component of the electric fans, how we construct the electric fan and what are the basic requirement, what are the basic machinery behind the electric fan and what component we use. The first important component is the capacitor, that is the start capacitor which is used in the electric fan. As we all know that the capacitor stores energy and this stored energy is used to rotate a fan from the rest state. So, it is very clear the capacitor is used to rotate a fan from the rest state to the motion state. So, this capacitor increases the electric fan motor's torque and allows motor to rotate rapidly. The function of the capacitor, the first important component is the capacitor, and the function of the capacitor is allow the motor to rotate. It means it gives the rotation to the fan. This capacitor remains into the circuit until only the electric fan reaches predetermined speed, and this predetermined speed is usually the 75% of the full speed of the fan. When the fan reaches the predetermined speed, this capacitor is taken out of the circuit. It means this is used to rotate the fan, and whenever the predetermined speed is reached, then this capacitor is taken out of the circuit and will again to incorporated into the circuit when fan comes at the rest state. Next important part is the axle. This axle or the shaft is the metallic rod and mostly made up of a mild steel. This axle is connected from the ceiling to the fan housing and it stays at the rest motion while bearing supporting the housing over it rotates, and it's also the arrangement of the and it has the arrangement for transfer of the current to the stator windings. So, another part is the bearing. Bearing are the ball bearings and these are used in the electric fans. As we can see in the fans that the two bearing which are linked between the housing and the axle gives the rotary motion to the housing. By using this, the motion can be done, rotary motion can be done in the housing system. So, what is housing? Again we are using housing. What is this housing? Housing is the outer part of the electric fan which carries the stator, rotor and drive shaft bearing assembly on inside and blades on outside. I mean, this housing containing the capacitor, bearing, rotor, moreover the stator and that compact in this housing, and this housing the blades are attached outside from this housing. This is very clear. Next is the blades. Blades plays very important. Blades or the wings are the hanging part blotted on the outer area of the housing, and the 3 or the 4 blades are mostly used, and their length and the angle of the air throw depends on the size and the capacity of the electric motor we are using. Another important point is the working principle of the electric fan. Electric fan works on the principle of the conversion of the electric energy into the mechanical energy by means of the magnetic field, or in this case the mechanical energy is consumed as the rotary motion of the fan blades. So, there is a conversion of the electric into the mechanical. So, when the AC is supplied to the electric fans, alternate current supplied to the electric fan, it first reaches the capacitor and then capacitor delivers high energy to the stator windings. So, when the stator windings energized, so it develops the rotating magnetic field and which forces the rotor to rotate in the direction of rotating magnetic field. So, this type in this way electrical energy is converted into the mechanical energy, which causes the rotor and the housing to spin, and the blade attached to the housing throws away the air near it while creating the cooling effect. So, then the stator winding energized, it develops a rotating magnetic field and which forces the rotor to rotate in the direction of the rotating magnetic field, and that will create the cooling effect. What is the fan specification? This is a very important part when we select the fan. Then what specification we require? So, and what parameter we require? So, the right specification of the parameters of the fan at initial stage is the prerequisite for choosing the appropriate and the energy efficient fans. So, in this what we have, the user should specify the following information to the fan manufacturer to enable the right selection. Number 1 is the design operating point of the fan, that must be the volume and the pressure of the fan. Another point is important, that is a normal operating point. Volume and pressure maximum continuous rating is required for this operation. Next point is the low load operation. This is the particularly essential for the units which is the initial few years may operate at the lower capacities with the plans for the upgradation at the later stage. The initial low load and the later higher load operations requirements needs to be specified clearly, so that the manufacturers can supply the fan which can meet both the requirements with a different size of the impeller. It means if you can modify, then previously we can modify from the low load to the higher load. There should be a chance for the upgradation of the fan. Another is the ambient temperature. The ambient temperature, both the maximum and the minimum, are to be specified to the supplier. So, this affects the choice of the material of construction of the impeller. Another, the maximum temperature of the gas at the fan during upset conditions should be specified to the supplier, where we are using this type of fan and what is the pressure of the air, that also the requirement for the construction of the fans, and this will enable choice the right material of the required creep state. Density of the gas at different temperature at the fan outlet. Another is the composition of the gas. This is very important for choosing the material of construction of the fan. Next is the dust concentration and the nature of the dust. The dust concentration and the nature of the dust are also should be clearly specified. The proposed control mechanism that are going to be used for controlling the fan. The operating frequency varies from plant to plant, that depending on the source of the power supply. Since this has a direct effect on the speed of the fan, the frequency prevailing or being maintained in the plant also needs to specify to the supplier. Now, another part is the fan performance. Fan performance, moreover, it is a evaluation efficiency of the system operation. What is the performance of a fan and how efficiently it is working. That will be defined by the various characteristics like system characteristics, like fan characteristics. What is this system characteristics? Where we take the system resistance is used when referring to the static pressure. So, the system resistance is a sum of the static pressure loses in the system. The system resistance in the is the function of the configuration of the ducts, pickups, elbows and the pressure drop across the equipment. For example, we use the back filter or the cyclone. The system resistance varies with the square of the volume of the air flowing through the system. Moreover, for a given volume of the air, the fan in the system with narrow ducts and multiple short radius elbows is going to have work harder to overcome a greater system resistance, and it would in the system with a larger ducts and the minimum number of the long radius turns. So, next is the long narrow ducts with the many blades and twists will require more energy to pull the air through them. So, consequently, for a given fan speed, the fan will be able to pull less air through this system than through a short system with no elbows. The system resistance increases subsequently, and that volume of the air flows through the system increases, square of the air flow. Moreover, conversely, resistance decreases as the flow decreases. To determine that volume the fan will produce, it is therefore necessary to know the system resistance characteristics. So, you see on the screen that this is the system characteristics. So, the existing system, the system resistance can be measured in the system that have been designed but not built. The system resistance must be calculated, and this type of curve generated in the system resistance. There is for the various flow rates on the x axis and associated resistance on the y axis. At x axis we are having the various flow, and the y axis we have the associated resistance. Now, next is the fan system characteristics. Now, the fan characteristics. The fan characteristics can be represented in the form of the fan curve. The fan curve is performance curve for a particular fan under a specific set of conditions. So, when we take the characteristics of fan, then we take the curve of the fan, and that will define the performance curve of the fan. The fan curve is a graphical representation of a number of the interrelated parameters. Typically, a curve will be developed for a given set of the condition, usually including the fan volume, system static pressure, fan speed and brake horsepower required to drive the fan under the stated condition. So, some fan Curves will also include an efficiency curve so that the system designer will know where on that curve the fan will be operating under the chosen conditions. So, in many curves as shown in the figure, the curve static versus flow is especially important. So, you see this is the on the screen we are having the characteristics curve of the fan. So, intersection of the system curve and the static pressure curve defines the operating point, where we have the intersection. All these intersection define the operating point, and moreover the system, these are the intersection that define the operating point. When the system resistance changes, the operating point also changes. It means the system curve depend upon the resistance. If it changes, the operating point will change. The intersection of these two system curves and the static pressure curve will change. So, once the operating point is fixed, when we fixed the intersection fixed, operating point is fixed, the power required could be found by flowing a vertical line that passes, you see here that there is a vertical line that the flowing a vertical line that passes through the operating point to an intersection with the power curve. So, horizontal line here we are defining the horizontal line drawn through an intersection with the power curve will lead to the required power on the right vertical axis, and in the depicted curve the fan efficiency curve is also presented. So, we can find out the fan efficiency. Next is the fan laws. Fans operate under a predictable set of the laws concerning speed, power and pressure, moreover the volume. A change in the speed means rotation per minute of any fan will predictably change the pressure rise and the power necessary to operate it at a new rotation per minute. So, here with the variation of the RPM by 10% decreases or increases air delivery by 10%. You see on the left hand side, that is define the flow versus speed. Next is the pressure versus speed square. Next is the power versus speed square. So, this must keep in mind whenever the construction of the fans. So, these are the curves like flow versus flow directly proportional to speed, pressure directly proportional to speed square, or the power directly proportional to the speed cube. So, these are the points where we keep in mind this construction of the fans. Fan design and the selection criteria is also important. Precise determination of the airflow and required outlet pressure are the most important in the proper selection of the fan type and the size. The airflow required depends on the process requirement, normally determined from the heat transfer rates or combustion air or the flue gas quantity to be handled. System pressure requirement is usually more difficult to compute or the predict. Moreover, the fan design is also important. Detailed analysis should be carried out to determine the pressure drop across the length, bands, contractions and the expansions in the ducting system. So, pressure drop across the filter drop in the branch line and extra the important. The pressure drops should be added to any fixed pressure required by the process. Moreover, frequently a very conservative approach is adopted, allocating the large safety margins, resulting in oversized fan which operates at flow rates much below their design value and consequently at a poor efficiency. So, the point is that the efficiency should be high in the fan. Thank you very much.